So this lesson is about what are called second derivatives. The second derivative, which you should not refer to as the double derivative, even though some people do, that's not actually correct. The second derivative is the derivative of the derivative. So you take the derivative first, like you normally would. That becomes a new function, and then you take the derivative of that, and that's called the second derivative. So as far as notation is concerned, of course, there are the two types of notation for describing derivatives. So if you have a function, let's say y equals f of x, that'd be the original function, then dy over dx, or f prime of x, is what we called the derivative, but now we're going to call it the first derivative. And then d squared y over dx squared, or f double prime of x, is known as the second derivative. Now it's important to notice that the square on the numerator is on the d, and the square on the denominator is actually on the entire dx, but it's after the x. So the y is not being squared here when you use this notation. Now, it doesn't actually mean you're squaring anything. It just means you're taking the derivative twice. That's just the notation. Just like over here, you're taking the prime of the prime, so the derivative of the derivative. So either of these notations are fine. Obviously, you need to get used to both of them. But these are called the second derivatives. So let's just look at some examples. So here we go. We have f of x equals x cubed minus 3 over x, and the question is to find f double prime of x. So first of all, I'm going to write f of x a little differently because I don't like that 3 over x. So it's going to be x cubed minus 3x to the negative 1. And then I would take its derivative, so f prime of x is going to be 3x squared, and then minus 3 times, and then x to the negative 1, the derivative is negative 1x to the negative 2. And so when I simplify that, that's just 3x squared plus 3x to the negative 2. And of course, I could have just gone directly from here to here without too much trouble just by multiplying the negative 1 times the negative 3. But anyway, here is the first derivative. And this is written in a convenient way for taking derivatives again, so I'm going to do it again. So if that's the first derivative, then the second derivative, which is called f double prime of x, is now going to be the derivative of 3x squared is 6x, and the derivative of plus 3x and negative 2 is going to be minus 6 x to the negative 3. And again, you could simplify this if you wanted to, but that's not the point of the lesson today. It's just to find the second derivative, at least not for this particular example. So this is now the second derivative. So you take the derivative and then you take the derivative of that answer. Here's another one. I want to find d squared y over dx squared if y equals x cosine x plus 1 over x. So first of all, I'm going to write y a little differently. It's going to be x cosine x plus x to the negative 1. And then I recognize that this is a product, so I have to use the product rule on it. And of course, this one is relatively straightforward, so I'll be able to take the derivative of this term without too much trouble. So again, I have to take the first derivative, which we used to call just the derivative. So dy over dx equals, and now from the product rule, I take the derivative of the first function here, which is x. So the derivative of x is 1. And then times the second function left alone, so times the cosine x, plus, now I take the derivative of the second function, which is cosine x. The derivative of cosine x is negative sine x, and then times the first function, which was x, left alone, so times x. And so that now is the derivative, using the product rule, of this term of the function. So now I need to take the derivative of x to the negative 1. It's going to be negative x to the negative 2. So now, of course, before going any further, it is actually going to be helpful to do some simplifying here rather than just trying to take the derivative of this thing as is. So I'm going to rewrite dy dx a little bit, and I'm going to call it, well, 1 times cosine x is just cosine x. And then I'm going to call it minus x sine x, and then minus x to the negative 2. So that is now the first derivative. Now I need to take the derivative of this first derivative to get the second derivative. This is going to be relatively straightforward. This will be a product rule because of the x times sine x, but don't forget there's a minus sign in front, so I'll have to keep that in parentheses and then distribute the minus afterwards. And then this again will be a relatively straightforward term to take the derivative. So let's go ahead and do that. So d squared y over dx squared is equal to, well, the derivative of cosine x is negative sine x, and then minus, and I'm going to do parentheses for this product that I have to take the derivative of. So forget the minus sign. I've taken that and put it over here. So it's just x sine x that I'm taking the derivative of. So the derivative of x is 1, and then times the sine x left alone, plus the derivative of sine x, which is cosine x, and then times the x left alone. And again, I put the minus sign here and then parentheses around this final product rule answer, and then I'll distribute that minus sign when I'm done. And now I finally have to take the derivative of negative x to the negative 2, so it's going to be plus 2x to the negative 3. And now I'm ready to simplify this and combine like terms, etc. It's not really necessary, but I'm going to do it anyway because it's not too bad. So d squared y over dx squared equals, so I'll notice that this is negative sine x. It's another negative sine x, so it becomes negative 2 sine x. And then minus the cosine x times x, or minus x cosine x. And then finally plus 2x to the negative 3. And that is the second derivative, or d squared y over dx squared. Okay, if f of x equals 2/3 sine of 3x, find f double prime of 2 pi over 9. So we're trying to find the second derivative when x equals 2 pi over 9. So we would find the second derivative first without worrying about the 2 pi over 9, find f double prime of x, and then afterwards we plug the 2 pi over 9 into x and see what happens. So let's go ahead and take the derivative. So if f of x equals 2/3 sine of 3x, I recognize that this is the 2/3 a coefficient, so that's convenient, but the 3x gets a box. It's a chain rule problem. So the derivative, the first derivative, f prime of x, becomes 2/3, and then derivative of sine of box is just cosine of box, so cosine of box. And then, because of the chain rule, times the derivative of the box, the derivative of 3x is just 3, and of course I backfill the 3x. So now, this 3 here is actually a 3 over 1, and it's part of the coefficient, so it pairs up with the 2/3. So 3 over 1 times 2/3 ends up just being 2. So this is 2 cosine of 3x. So that is the first derivative, and it is worth simplifying the first derivative so that we can take the second derivative, do something with the first derivative. It makes my life easier if I've done some simplifying. So now I need to take the second derivative, and I recognize I've got another chain rule again, surprise, surprise. So I'm going to put a box around the 3x. This time I'll use a red box. And now I need to take the derivative of that. So f double prime of x, well, the derivative of 2 cosine box is going to be negative 2 sine of box. And then by the chain rule, I got to multiply that by the derivative of the box. The derivative of 3x is just 3. And I backfill the 3x again. And then don't forget that this 3 is part of the coefficient here, so it multiplies by the negative 2. So I end up with negative 6 sine of 3x. Now that's f double prime of x. That is not f double prime of 2 pi over 9. So what I need to do is plug 2 pi over 9 in here for x and see what happens there. So f double prime now of 2 pi over 9 is negative 6 times sine of 3 times 2 pi over 9. Now to get 3 times 2 pi over 9, to simplify a little bit, I notice that it's really 3 over 1 here. So the 3 and the 9 will partially cancel, and so I'll end up with 2 pi over 3. So really what I'm doing is negative 6 sine of 2 pi over 3. And of course, from trigonometry, we know that sine of 2 pi over 3 is root 3 over 2. So it's negative 6 times root 3 over 2. Again, the 6 there, or the negative 6 technically, is negative 6 over 1. So I can simplify that and end up with negative 3 square root 3 because the negative 6 and the 2 partially canceled. And that's finally the f double prime value of 2 pi over 9, or the second derivative evaluated when x is 2 pi over 9. Now, just for edification, you don't really need this for IB, but it's useful to know that you can actually just keep these derivatives going, the third derivative, the fourth derivative, the whatever, the 17th derivative, and the notation goes as follows. So for the third derivative, the d cubed y over dx cubed, that follows our pattern that we had before. D to the fourth y over dx to the fourth, d to the 17th y over dx to the 17th. Notice that y is not raised to anything. That's because it's the function y, and it's the derivative of, the third derivative of, the fourth derivative of, the 17th derivative of y. Now, with the prime notation, you could just keep drawing more prime. So for triple prime, that's okay. I could do quadruple prime, and I could draw 17 dashes here, but you can see how that's going to get really tricky after a while. So we have this notation after the third derivative usually is to put a 4 in parentheses. It has to be in parentheses, because if I wrote f to the fourth of x, that would be like, let's say f of x was sine x, then f to the fourth of x would just be sine to the fourth of x, and that is not what the fourth derivative is. So if you want to talk about the fourth derivative, you must use, so this is not okay. So you must use these parentheses here to show it's the parentheses 4. So fourth derivative, parentheses 17, so 17th derivative, etc. Now, luckily for you, for IB, you don't need to know this, but I just thought I would show you so you've seen it at some point, and maybe you might use it later. And that is the end of today's lesson.